Aluminum atom is composed of 13 protons, 14 neutrons, and 13 electrons. This element is relatively inexpensive. One study estimates that it takes only 5% of the energy to produce a primary metal to recycle it. That's better for the environment. Aluminum is a substance that may be divided into two subgroups, heat susceptible and non-heat responsive. This element is known for its little impact on the natural world. The latter is the most popular category. In this category, the alloys are thermally exposed at a constant linear heating rate. The heat-affected zone is called OS. There are two basic types of aluminum alloys. These are wrought and cast aluminum. Wrought aluminum is manufactured by melting aluminum ingots with a specific alloying element. The molten aluminum can then flexibly take the shape of mold cavities. Attempts to physically derive aluminum started in the 1760s. The first successful attempt came in 1825. It was achieved by German chemist Friedrich Wöhler. He discovered that potassium and anhydrous aluminum chloride react to form a new metal. The method that Wöhler used was improved by Henri-Étienne Saint-Clair Deville in 1854. This allowed for the commercial production of aluminum. The process was patented in 1885. However, the actual production of aluminum was a slow process. It brought a long time to perfect a method for producing aluminum in large quantities. The cost of producing an ounce of aluminum was equal to the wages of a construction worker. The discovery of aluminum bound the efforts of a number of individuals. Sir Humphry Davy, a British chemist, first theorized the method of producing aluminum in the early 1800s. He also developed the concept of electrolytic reduction. This procedure helped to separate aluminum from its ores and oxides. In France, Paul Héroult was working on the same problem. He found a simpler and more cost-effective process for commercially producing aluminum. He also found that aluminum was highly resistant to corrosion. Meanwhile, in the United States, Charles Martin Hall was a college student. He was interested in the problem of producing aluminum and began to experiment. His research eventually changed the way aluminum was viewed as a semi-precious metal. Approximately 8% of Earth's core is made up of this metal, putting it among the least common. Bauxite is a rich source of aluminum. It contains about 60% aluminum hydroxide. It is a mixture of boehmite and gibbsite. The bauxite is processed through an electrolytic process to extract aluminum. Another source of aluminum is aluminosilicates, such as mica and clay. These are plentiful in nature. The first commercial exploitation of aluminum took place in the late 19th century. It was produced by Charles Martin Hall, who worked in a woodshed with his sister. He applied a high voltage to separate the aluminum from the oxygen. Some of the most common alloys of aluminum include copper, magnesium, and silicon. The tensile strength, workability and machinability of these alloys are of important considerations. Aluminum has an oxide coating that prevents it from rusting in the air and corroding in water. Aluminum is one of the lightest engineering metals. Its density is 2.7 grams per cubic centimeter, about 1/3 of steel. It has a good conductivity to weight ratio. This element is also extremely durable. It has good corrosion resistance and low melting point. Moreover, their machinability can be improved by careful control of alloy composition and the different kind of parameters. Such substances are lightweight, yet they also transfer electricity and heat well. It has superior mechanical qualities and can be welded without much difficulty. The compressive tenacity and flexibility of aluminum are among its most notable characteristics. In addition, it conducts heat well. Finer grains produce superior toughness and higher strength. However, other strengthening mechanisms can reduce ductility. Another important property of aluminum is its ability to be recycled. It is one of the easiest structural materials to recycle. Among the most popular metals, aluminum has a broad variety of commercial uses. It is an excellent candidate for electrical and thermal applications. Aluminum is used in power transmission lines and automobiles, making its parts lighter and more fuel efficient. Aluminum is used for a wide variety of purposes in the transportation, aerospace, and maritime sector. These include lightweight hulls, superstructures, and suspensions. They also offer significant weight savings, improved fuel efficiency, and enhanced safety. These alloys are considered to be very competitive with steel. Brake parts, gearbox shelter, and handlebars are just some of the many automotive uses for these aluminum alloys. They can also be used to replace polymer-based composites. In addition to its numerous industrial applications, aluminum has many uses in the consumer durables industry. Particularly, aluminum finds use in climate control and food storage devices. Aluminum is a popular non-ferrous metal because of its versatility. In particular, aluminum magnesium silicon alloys are very popular in automotive applications. Aligning aluminum's characteristics with those of other metals is a common practice. Its unique combination of mechanical, thermal, and electrochemical properties. It can also be used to absorb crash forces, making it an excellent safety feature. In addition, it is used to clad windows and doors in buildings, as well as provide foil insulation.